So let's get started. Katerina, do you want to launch the title of the last session for your series?
Yeah, so this is the last session that I've got for Python for full stack web developers, turning your ideas into products. I'm a senior engineering manager at a startup company called Kojo. We're a procurement solutions startup focusing on the construction industry. I've been managing teams now for probably about 6 years, and I've been in software for a little over 10. I really like a balance in my project management between agile and, pulling in the best parts of waterfall for planning so that you have a smooth project with visibility as well. So that's what I've been talking about in these sessions. As a bit of a recap for anybody who hasn't joined us before, the project has been to build an open source menu and ordering system that can tie into like delivery app client apps. It's meant to be single tenant, backend, and peer-to-peer discovery. So the premise really is, all of the delivery ordering apps, they're all proprietary. They take a lot of overhead for what it is that they provide. It's not actually that hard to model and make a back end that other people could potentially write front ends on, as long as we develop a open source, basically a API system, and then people could host it themselves. So far with this project, we've talked about PRDs, which are product requirements documents, the definition of what we're building, list of product specifications. We've talked about the TDD, the technical design document. It's typically written by the lead engineer or the lead engineer on the project. Defines how are we going to build it with the approach, any interfaces, and the technical specs. The work breakdown, which is oftentimes just straight part of the TDD, but that is, what do we need to do? It's a literal enumeration of the tasks and the tickets so that you can develop a schedule, which helps lay out dependencies, determines how many people you need to work on it, the order of operations, and then it gives you something that you can track against the plan. We've also discussed a few optional project documents, including process flow diagrams, wireframes, architectural and model database diagrams. I love diagrams. I use diagrams as much as possible when documenting things, because I think that a picture really is worth 1,000 words, and it can often help people understand what you're talking about very quickly. So I have a GitHub repository where all of this is. This includes the project document templates and the actual project docs for this project, as well as a set of tutorials on basically how I set the project up and deployed it to AWS. And so all of those resources are available in this repository, along with the actual project, which has been growing and I've been iterating on. So for this session, I wanted to delve deeper into APIs. So API stands for Application Programming Interface. In programming, there are a ton of interfaces. It's literally like the definition of the boundary layer of a function, a class, or an application. And the reason why we use APIs is because it provides an interface that isn't going to change. So if I am a third party and I have an interface that you can interact with, you are going to be generally, hopefully, guaranteed that I'm not just going to change that interface out from underneath you. So it helps two owners of information and applications communicate with each other. And basically anything on this side of the interface is up for changing, right? But then the actual definition here, like that should not change. There's a whole bunch of stuff that like, the other person on the other side of that API is going to be relying on you keeping that API stable. And there's strategies for like deprecating. You might say, oh, we want to get rid of this endpoint eventually. You might start sending a deprecation warning, and then eventually you can, track the usage of that endpoint over time and eventually remove it when you're sure that nobody else is using it. There's also different ways to version APIs, but it's usually some kind of a business decision on how long you're going to keep APIs up and running and available. So yeah, once other people are connected to your API and running on it, you don't want to change it. That being said, right now, my project is very much new and in flux and nobody's using it. So I am free to change the API as much as I want in the meantime. So there's a number of different types of APIs, and I kind of wanted to go into this because I wanted to be clear that while I am using RESTful APIs, it's the kind of traditional get, put, post, delete verbs. It was based on a particular dissertation and HTTP specs, and these are references if you're interested. There are other types of API protocols. For example, SOAP is an older XML-based protocol that you do still occasionally see. And you usually see this if you are integrating against a third party that is very legacy. And so they put a lot of effort usually into building a SOAP API like way back in the day, and they have just never upgraded. And this is how you integrate against them. There's also GraphQL, which is newer, and it kind of, it's supposed to be thinking in graphs, basically, rather than like this verb and then like object or verb and list. Practically, I found that it splits up into queries and mutations. Query being basically the functionality of get, and then mutations being everything else. So if you're going to change stuff, it's a mutation. And if you're just going to get stuff, it's a get. But when you're integrating against third-party APIs, you might see a variety of these. So you always start with the documentation and making sure that you understand what the third party's documentation is providing for you. Now, there's no guarantee that that documentation is going to be accurate in the slightest, and I have definitely had jobs where I've been working with third-party APIs that I swear just lied in their documentation. So, yeah, the ideal is actually testing it and making sure that you understand it. But yeah, documentation is usually a good place to start. All right, so most third-party APIs are going to have some kind of authentication. One of the most secure ways to authenticate involves a multi-legged authentication and authorization. So authentication says, I am who I am, you are who you are. We know who that person is, it is the identity. And then authorization says, okay, I know who you are, and this is what you're allowed to do. And multi-legged basically involves usually a number of different calls that allow you to verify and transfer tokens back and forth, and can manage your secrets. Basically, as an industry, we went through a whole number of different iterations of OAuth, and we eventually got to OAuth 2.0, and that's kind of where it stayed for a while. But depending again on the third party, you may see a number of different versions of OAuth still available. But in actuality, most of the time, all I find is bearer tokens. So bearer tokens. I would say bearer tokens are not necessarily the safest thing to use. It's basically if you're, it's really easy to use, but it is not necessarily safe. The key part of bearer tokens is that they really need to be protected from disclosure in storage and in transport. So typically what happens is you as a developer will sign up for an API key, an account, and you'll get an API key. And then that API key needs to be kept super secret, because if anybody else gets it, they can use your API key, pretend to be you, have all the permissions you have, and potentially rack up bills against your API that you did not use. So there's usually a benefit to people attempting to find your API keys because then they get to use your resources for free. So some of the rules around your API keys: keep it confidential. If there is any chance that you leaked your key, rotate it. So go on back to your account, delete your old API key, get a new API key, make sure that the leak, whatever it is closed, and replace your API keys. Be really careful about API keys on the front end. You don't want them on the front end. It's really easy to find them on the front end. You can just go into the console and get them. So keep your API keys on the back end, provide an endpoint, and then from the front end, you can just call your own server and get the results of the query instead of attempting to call a third-party API directly from your front end. Definitely do not store your API keys directly in your code. If you ever accidentally put your API keys in your code, especially in Git, the safest thing to do is to rotate your API keys. So delete them out of your code, but then go ahead and rotate them, because you can go back and get history a lot of times and find API keys even if you remove them. So you would have to absolutely wipe the history to make sure that the API keys were not actually leaked. So yes, it's just much safer not to store your API keys in anything that is going to go into Git or in your code directly. And then store any key that costs money. Make sure it's encrypted. Make sure it's going to be transported over TLS. Consider a secrets manager. So be real careful with your API keys. All right. So the goal of this particular topic, basically, what I did was I integrated against a third party. So we're going to look at that a little bit in a demo, but I wanted to explain the basic pattern that I set up. So usually for working with any kind of third party, I will make myself what I call a gateway model. And so in the interests of separation of concerns, it's often useful to abstract your interactions with a third party to a gateway class. It provides you with a single place to manage URLs. It can handle authentication, however that third party handles authentication. You define parameters and options that you're going to use so that you don't necessarily have to use all of the parameters and options that the third party provides. You can, make decisions for how you are going to use it. And it provides a stable interface in your application code if you ever need to swap it out in the future. Actually have done a lot of swapping out third-party gateways. So, I would consider wrapping SDKs as well. SDKs are basically libraries that third parties will oftentimes write to make it easier to use their product, but you don't necessarily have to use them directly, especially if there's a chance that you might not want to use them in the future. So the other benefits of the gateway, you can swap them out on the fly, like literally at the same, if they're providing the same service, you can call one, you can see whether or not you got a successful response. And if you didn't, if it's down, you can call the other one. And some of the upfront planning that we do with this gateway model can really help future-proof things. It also gives you a straightforward place to mock out calls when you're testing, so unit testing. And it's always a good idea to mock any third-party interactions in your tests. Because it saves money. You're not going to repeatedly be making calls. It also speeds things up. You don't actually have to do the call during the test. You just have a defined value that you're going to return against. And one of my favorite tricks to do while testing is to turn off my internet and then run my tests and make sure that they still run. And that way I know that I'm not accidentally making third-party calls in my tests. And it shows me where I need to mock things out. All right. So I was working on the locations model this time. And I thought it would be cool for the purposes of this menu delivery restaurant app to utilize geolocations. So when thinking about geolocations, a user's location is considered high security. So if you're on an app, a mobile app, you have to ask for permission to see the user's location. And I'm sure you've seen those from the user's standpoint, but it is fairly straightforward. And if you have a purpose for it, it's perfectly fine to request location permissions. And the web can also request permission to share your location. These will come back as latitude and longitude, which is perfect. Latitude and longitude is a really good way to, it's a really good way to know where you are and where, other locations are. And so you can also just ask for the user's address. If they don't want to share their location specifically, but you need it, you can just say, okay, great, where are you? If you have a user's address in plain text, you can use a third-party API relatively cheaply to get a lat long, especially at the volumes that I anticipate working with for this project. I did a quick implementation with a third party called positionstack.com. And that has the added benefit of verifying that the address is real and not made up. And then IP address geolocation databases or other APIs, based on if you're basing it on the user's IP address, which you do have access to when they make a call against your service, the accuracy of these is not great. And VPNs can definitely mess with that. So you don't always get the real IP address if the user is going through a VPN. A lot of times you'll pay for like a database, and those can get out of date really quickly because IP addresses are not necessarily stable, they rotate. I found it most useful for checking for credit card fraud. So basically you've get the user's IP address, you look it up in one of these databases real fast, and you kind of check to make sure the country and the state are the same as the credit card. If they're not, then that becomes a flag in your credit card fraud monitoring service that this might not be real. But it's not going to be as helpful for something like, oh, I'm a client and I want to order from this restaurant, and I want to make sure that that restaurant is less than 10 miles away. All right. So here is what I did. All right, so from kind of the outside, I added an endpoint to the location with the detail. So this is the restaurant location ID. And then I added a custom distance method that takes a lat and a long. And when you do get, you get miles number as a float in this case. So my lat long is half a mile, a little more than half a mile away from my target restaurant here, whatever that is. And so let's open up the code. All right, so we're working here on the back end in these two major folders. The backend code I put in a directory called source src, and then there's some configuration in the server folder. And then if we start at the URLs, you can see that nothing really changed here. And nothing changed here because I'm using Django REST Framework's view set for location, and it's just going to, the router is just going to register the endpoint from the view set. So if I go look at the view set, what I did here is I added this custom distance method here, distance action. And this decorator comes from REST Framework. And I added detail equals true because I do want to get the ID of the restaurant location that I am targeting. We add methods equals get. And then the parameters, I just defined lat long. I could define it longer with like a full latitude, longitude, but I want to be able to use the parameters in the URL, and there are upper limits on those. So I wanted to kind of use abbreviations here anyway. And as long as I'm clear about what I'm defining, what those keys are called, this is fine for now. So we check to make sure that both lat and long are defined. And if not, it's a very simple validation at this point. There are other validations that we could do. We could check to make sure that they were floats. We could check to make sure that their ranges were appropriate for latitude and longitude. But for right now, the presence of it is probably fine. If something that was inappropriate leaked, you'd probably get a 500, which wouldn't be ideal because it's not necessarily the code's fault, it's the user's fault for putting in bad data. But that is how this will work for right now to keep it simple. So Django REST Framework provides a convenient method here to get object. This is going to get the object of the query set here that is the detail that was defined as the PK in the request. So this is the location of the restaurant. And then if we go look at the location object here, I've actually added two new columns, the latitude and longitude, to the table. Because every time you do a geo lookup on something, it's going to cost like a little bit. So if you do a geo lookup on something that is going to be as stable as the actual location of the restaurant, it's a really good idea to save it. So I put a place to save here. And then I made myself a US address model. And then I added a little method here on the model here that is just going to return a type of US address. Now, I did this partially because addresses can get really complicated, and they can be different depending on the country that you're in. And I wanted to kind of abstract this away a little bit so that if I needed to support addresses in different countries, there would be a convenient way to do that. So that's kind of why I abstracted away and I didn't build it straight into the database model, another separation of concerns. In this case, I'm just going to give the US address all of the information that I have about the address, text address, latitude, longitude. And let's go look at what this one is doing. Okay, so the US address in this case has access to two separate gateways that I built. I built one that is Geocode Maps and another one that is TomTom. And these gateways I put in this locations utils folder here. So one of the things that I did was I normalized the address. So if I get a text address in, one of the first things that I attempt to do is normalize it. So to normalize this, I didn't really want to use an API for this if I could avoid it, because that is potential costs. So instead, I pulled in a package called US address. And US address is a Python library that does its best to parse apart addresses into pieces. And so from this, I'm actually going to get a defined street number, name, sub addresses like suite or apartment, city, state, zip code, and I'll be able to fill those in. If it's a post office box, I'm raising an exception. I don't want to support post office boxes. We don't need to support post office boxes. And so then if I haven't geolocated already, this will call the Geocode Gateway, and it will do a search by text, and it will attempt to find the latitude, longitude. Now, one of the things that I haven't done yet is actually return this so that I can store it in the model, but that is something for the future. I have a little validate the geocode to make sure that I have both of them if I want to. And then I wrote myself an estimate distance function here. And this is a standard function that you can find. It's one of the, there's like several different ways to estimate distance based on latitude, longitude between 2 points. But this one's it's not bad. And so we do like a little bit of actual math with radians and sines and cosines, and then multiply by the radius of the Earth, and you get a decent enough estimate to tell whether or not you're within the radius of the delivery, if we're just doing a nice big circle around a particular restaurant. There are different things that you could think of that like different product features that you might be able to support with a more advanced set of rules and information if you're able to get it or you wanted to pay for it. You could totally imagine like driving directions or allowing a restaurant manager to specify particular neighborhoods that they wanted to support and not others, so that it wasn't a simple, circle. But this one was fairly straightforward to do for at least an estimate and potentially a fallback. It's always nice to have a simple fallback in case APIs that you are dependent on aren't working. You can still return some kind of a result. So this one is the network-free version of that. And then I also added a method here for driving distance. And this one uses the routes gateway, which I based it on TomTom. And that is literally just going to hit this gateway's get route method. And then from this, I could probably do a little cleanup so I don't have to know routes in summary, but it returns length in meters and travel time in seconds. And so I'm going to return length in kilometers and travel time in minutes, or length in miles and travel time in minutes, as just a couple out of this function. All right, so let's go look at the gateways. So this is the Geocode Gateway. And this is literally with the URL geocode.maps.co/search. And it requires a query parameter queue and not much else. This was a very convenient little freebie geocoding API. Basically I use the requests package. Request is really handy, and did a little bit of validation, and I'm returning display name, latitude, and longitude. This is the position stack gateway, and well, actually, this one should probably be more like this. I was going to use it. I got myself a position stack API key, but I found that it was down all weekend. So it had been doing pretty well up until maybe like Friday, and then it collapsed. So I was actually unable to get a positive response out of position stack, but if I had, this is one of those bare key situations where you literally just pass the key in the parameter payload. So it was good that I had a little gateway because I was able to swap it out really quickly for the geocode maps. And then here's the TomTom Gateway, which was a little more complicated, but it's available at api.tomtom.com. And it actually had really good documentation, but it has a ton of options. And I basically just put the request from its example here in the comments. But you can set all kinds of things like types of vehicles, and whether or not you want to include traffic, and whether or not you're driving a commercial vehicle, so that if you have to route it around someplace, you can. But most of those are very optional. So I am only using latitude, longitude, which gets added to the URL, basically straight in the URL, along with a couple of preferences and specific headers that it asked for. And that worked really well. So one of the things that I like to do while I'm working on a gateway is add tests. So my unit tests are here. And basically I set up a address text case here. I'm more or less testing US addresses, the US address model here. And so I set myself up with a San Francisco address, a New York address, another address that is near the original San Francisco address, and another one that is near New York. And if we look at the test cases, I was able to first make sure that it was parsing correctly with the original US addresses library. That was actually a little tricky. Some things like East 51st Street, getting that whole thing together as the street name was a bit tricky. Kansas City together as the city was a little tricky. And then here I do the address, validate address in geocode, and then I'm going to check the geocode and make sure that it comes back and it is the same. And this one I mocked. I went ahead and I used the patch object to mock specifically the gateway search by text and just return my return value, which is in fact coming out of this static method here, which I put the whole value of this return. This one's the response from TomTom. So I just copied the response from TomTom originally into this file, so I wouldn't have to hit it again and again. But as you can see, it's going to return like the points in the steps along the route as well, which could be useful for later for actual driving directions. So I figured I may as well save it, and now I don't have to hit it again until I want to basically re-record. And so then, yeah, that's this one, get route, is using get route response. And yeah, so just to kind of sanity check, address 1, address 2, it's a little more than half a mile, or 0.77 kilometers. The distance between my San Francisco and my New York address is 2,566 miles, which I did check on Google Maps, and it's not that far off. And then travel miles was 1.68, which makes a little bit of sense because it's not just as the crow flies. It's more like, okay, how much driving do I actually have to do? But it's also only about like 9.5 minutes. So that also kind of makes sense with the points that I picked. Yeah. So if we go back, it's basically all the way down here. So yeah, at this point, I can use my fun alias make tests to run them, and they work, and that is lovely. And I can go back over here to my Swagger, and I can actually change stuff up a little bit and make sure that it's still working. So if I increase the latitude by 1, then it's 69.5 miles instead. So that's cool. And if I do maybe subtract 1 there, 87.9 miles. So that's all. That's actually going ahead and hitting the endpoint and doing the calculation for an estimate. So yeah.
I felt like you kind of like sped through that session. So it's like a lot of content, like always, like every session in the series. I guess one question is, like you said before, right? Sometimes like the API goes down, right? Like, and you contacted people, wasn't sure. Like, what if it's something you're doing for work versus the project? Like, what can I do to help de-escalate it to like my manager?
So one of the things that you can do is be really clear about your error messaging. And so depending on how critical the thing is, or where in your workflow, how you're depending on the service. First off, your manager or your manager's manager, as the case may be, should be setting up contracts with SLAs with your third parties. And those usually have a given amount of uptime. So if they have a high uptime, then you can usually get away with like, okay, like especially at a startup, if it goes down, we're going to surface an error to the front end and say like we're temporarily unavailable, or that feature is temporarily unavailable, try again later. And meanwhile, everybody in infrastructure is going slightly nuts and trying to get it back up, or you're calling your third party and you're saying, hey, get it back up. When's it going to be back up? And you're spamming the status page and you're like, oh my God, it's down. It's
Oh, you
down.
mean like the Amazon web servers go down, just like, oh,
Oh
half
my
the
God,
internet's done.
At that point, just close your computer, go home, take a break, go to the beach, right? So like that is usually fine. Now, if you're working on something that needs to be high availability, one of the best ways that you can deal with that is redundancy. And that is where you integrate against more than one service that is going to give you the same thing. And so, for example, while I was working in the payment space, we were, my company, still kind of small, we were highly dependent on like one payment processor. And so if that payment processor ever went down, or if they erred, or if they couldn't handle payments in a particular place, then that person was just not going to be able to pay. And we might say, oh, contact customer service. And that was like, the resolution was contact customer service, and they're going to try to talk you in to a different way to pay. But what a lot of companies did was they made contracts and deals with multiple third-party payments. And so you could actually like on the fly decide which payment processor you wanted to use. And so it was good for the redundancy of what if it's down, but it was also good for, I know that this company is cheaper in this area, so I'm going to use the cheaper one first, and only if it errors am I going to fall back to the more expensive one. Or I heard that like some of the bigger companies would play them off of each other and try to drive the prices on down. They'd be like, oh, as long as they're giving me a better price, I'm going to use them more, and I'm going to funnel, certain percentage towards this one or that one. So it could get really complex. But yeah, this is not getting quite
It's
there.
like it's a whole different new series just to cover all that content, right?
Yeah, no, you can set up machine learning to help you determine which payment processor to use at the end of the day. But yeah.
Okay. No, I guess another follow-up question. Like, feel free to post in QA or in the chat if you have any questions about the series. I know our previous videos and slide decks, previous videos are on YouTube, and previous slide decks are on GitHub. So
yeah,
you can see it there. I guess another one is like, I think, are you using Windows or Mac for your computer?
I am on a Mac.
Okay.
I basically only program on Mac, but you can program on Windows. Because I've got it set up in a Docker container, you can run it. You should be able to run it on Windows. Okay. The one thing that I think doesn't work out of the box on Windows is my make aliases, but they are just aliases, and you can always kind of look in the file and copy paste, or just use the commands directly, or set up your own aliases a different way. That's more of a convenience.
Are there any other major differences? I know also do like both sides do like, a VM, right? A virtual machine. Yeah.
I mean, like Docker, the point of Docker is so that you can cross different types of machines without issues.
Okay. I guess another thing people mentioned is like APIs. Thinking my English literature background citation stuff. The API, sometimes there's too many calls, right? Like, is that something? How do you balance for that? Like, that it will be like a little bit popular, but you don't want it to go. Boom.
Yeah. So you can rate limit your calls. A lot of times, you can rate limit outgoing calls if you're going to use it, so prevent people from spamming it. Basically, if the same person comes in, spamming things, then you can just turn them off. Okay. You can also cache, and caching responses is a good thing to do at that intermediate layer. You don't necessarily have to do it in the application layer, but you can put caching services in like in the deployment layer, in the box layer, you can add a caching system on the edges. And that'll help with like repeated calls or similar calls. But for things like if I'm going to geolocate stuff, just storing it in the database and making sure that I check there first before calling the API is usually pretty good, because database calls are free.
Yeah, it's just fail safe. Yeah.
Yeah. So like I generally like to save any calls that I'm paying for. I want to save them somewhere.
Yeah, I think I saw someone mentioned they did a test call and they got charged $3.
Oh, easy. Yeah. I made a key error where I gave some interns an API key and they ended up costing me $1,000. So that was on me.
Yeah, well, you know, it's you learn from your mistake.
Learn, you do learn. Once
expensive. It was only 1,000, right? It wasn't $10,000.
It wasn't 10. Oh man, it could have been. I realized what they were doing.
So
at least I realized what they were doing pretty quick and changed the key on them. But yeah.
Oop, I see another question in chat. So maybe this is a someone attempt you might join a bit later. Saying not sure if missed this section, but they're asking, did you build your own API for the front end?
Yep.
And use 2 third parties to build it?
So my service itself is an API. So that is the goal of this project, is to build a server that is providing an API to a front end, to a as yet undeveloped front end. And I have developed a minor amount of admin front end, but not the client side front end. The goal is to allow clients, like client mobile apps eventually, to go ahead and just, hit my services. Those ones are just going to be basically cross-site. I'm not putting authentication on it.
It's still open source project, right? Yeah.
I'm going to have a defined set of public APIs that are going to be basically unauthenticated at that point. Or maybe use some kind of open authentication for like, sign in with Google or whatever. Might be a direction to go for, especially if you have to handle payments or types of things, but it's just honestly shouldn't be that bad.
And there's like a follow-up question to that, asking about like the builds. So like clarify, I'm not sure if you already answered this, so correct me if I'm wrong, but like if one of like, I guess the APIs is down, or maybe the build, what is down, do you switch to the second one? Or what's
so
your
with the
solution?
third-party API right now, I did not dynamically switch it. I just have it in the code. It is available, but I could dynamically switch it. I could pick one if I thought it was cheaper, or if I, if one of them gives me like 1,000 calls a month, and I'm like, okay, I'm going to use 1,000 calls a month on this one, and then anything over, I'm going to switch to this other one. I could do that. I could count up my calls and I could save them somewhere, and I could switch depending on what time of the month it was or how many calls I had already made. There's a whole bunch of different things that you could do, and is probably worth considering when you are working with third-party APIs and trying to keep costs down. So that is some of the things that you can do.
Yeah, that's a great question we had. Another thing you can ask before we end the series. Did you have any recommendations for like, I guess, other learning tutorials? I'm sure it's disappearing. Other tutorials or like books, podcasts, like somewhere else where you want to like stay up to date on this stuff, Katerina? I know like we need like Googling, like, do the keywords, but like, yeah.
I'll say yeah, a lot of it's out there. It's been a while since I went through the learning phase of this, and honestly, like my choices of technology are a little bit old, and it's probably showing. So I don't know that I have the
You know
most,
it works because it's older, right? And it's still kicking.
it works, and it's just really easy for me to set up. So I thought I'd share. But yeah, there's probably, you know, newer and more modern stuff out there. For example, like I am not currently using any of the type checking in Python because, you know, when I grew up, like we didn't have types in Python. So,
Well, they're all, or I think each version language is now backward compatible,
yeah,
right? Yeah, so it's nice about Python.
yeah.
Yeah.
But yeah, Women Who Code have
Got a lot of videos.
fantastic set of videos. So highly recommend.
Okay. I guess the last thing that we could add to, usually in October, there's Hacktoberfest with, is it DigitalOcean, I think, and GitHub.
Oh.
And there's a lot of like open source projects happening at that time. So if like you also wanted to build your own like open source project or build, you can look up ideas in there. Like yours, like Katerina, you said like you want to do like the food delivery or food ordering service. But, you know, like what else could you do that could be like, you know, open source? Like I think I saw one where one company, like, you know, they're like booking boats and like over the island, and eventually went to like got that like service software on like bookings.com.
Yeah.
Right. But like your booking boats is like kind of hard because it's like the people who are owning boats and trying to do that business, it's very like face-to-face personal interaction. But if you're not internet savvy, it's daunting.
I will say like open source is an excellent way to get experience actually programming, to get you know, like examples of your code to show an interest in coding to future employers. When I first started coding, I was self-taught, so I did a whole bunch of like just pushing all my code to GitHub, and I came up with a project, and it was a library that wrote PDFs.
Nice.
And so I actually ended up getting like my first job off of that library. And they were like, okay, like, come help us use the library at our company and finish it off. So for like the first month at my, you know, brand new junior engineering job, I just finished off my open source library until the point where we could use it at the company.
I remember like a lot of people, they still just do create PDFs by hand, open Excel, copy the data, paste in the document Word, save, and like a lot of it could just be automated if they.
My goal was to, my goal was really to like write these templates in Python that were all programmatic, and then, you know, pull the data out of the database and spit out a PDF, and now you don't have to touch it.
Yeah, it's like, it's so efficient, right? So
yeah. And I learned way more about PDFs than I'd ever thought I could, and that you would ever want to. So,
so that's your next series, like, you know, PDF expert.
I have a presentation on PDFs if you're interested.
Well, maybe like in the fall. I know you really did an awesome job like carrying like the series every 2 weeks. So I do want to enjoy like the sunshine.
I'm gonna enjoy the sunshine, but I would like to keep working on this, and it's been a lot of fun, you know, having something to work towards every couple of weeks to show off to people. So it was keeping me on track. So thank you all.
I thank everyone for sticking with us through the series. And I think you're also I don't know if we mentioned a previous event, but you are now a lead at Women Who Code Python, so you'll be in the community for, you know, a bit longer. And if people have questions watching this video recording, you can join our global Women Who Code Python Slack community and channel web-dev-study-group.
Yep. And feel free to check out all the resources on it, and it should be all there. And
I know, it's always
feel free to participate. I'm taking pull requests.
It's never ending.
Yep.
Great. Okay, so I'll wrap up tonight's session. Thank you everyone for joining us and with the series. So good morning, good afternoon, good evening, wherever you are. I hope everyone has a great rest of August. Okay, bye.
Thank you.